Next in this session, we'll see static variables. Okay. So we already saw local variables and global variables. What we know is global variables have a scope of a full function execution or a program execution, whereas local variables have a scope of only in the function. Okay. When the function exits, the local variables get destroyed. But what are these static variables? You might have seen it many times while writing a code or while analyzing a code, or you might have come across in any books. A static variable. These are nothing but these are like global variables, but whereas the scope of these can be limited to file. Okay? And also the static variables which can limit the scope only to the function, like a local variable. But the only difference is, since static variables are like global, they occupy a fixed memory. So the value is persistent. Even when you call next time, it will have a value which is stored before. Yeah. So I'll just show you an example what I meant and how the static variables are function scope and file scope. Okay. So let me open code blocks and show you. So here I have code block. Let me arrange it here for you. And I'll just write one function. First, let me define a static variable which is only file scope. Okay. So here no difference. It just looks like a global variable, but whereas we can only use it in this file. Later, after this, we will see how to use multiple files and share a global variable from one file to the other file. Okay. So here, and we say I'll just write value of a, yeah, whereas I'll update the value of a to 20. And I can use the same in this function also. A equal to 30. Value of a. Yeah. And after printing here, I will call function one here, and I want one new line. Okay, it is compiled. So first it is 20 and then 30. So we are able to use a static variable just like a global variable. Okay, so this we already know. Now let's see how to use it as a file scope. What I'll do, I'll just change it from here and add it here. Okay, so now this is under file scope, function scope. So it should give us a compilation error. Let's see. We already see a compilation error here. Undeclared variable a. Okay. So next, what I'll do, I want to show you a use case of a variable, static variable present in with the file scope, with the function scope. Okay, why do we need it? Okay, because it just acted like a normal local variable, correct? So why do we need it? So I'll just have a static variable a equal to 10. Okay. Yeah, I'll just have a variable a equal to 10. Okay, this is static, local static, and I want to do a equal to a plus 10. Okay. Now, and I'm calling the main function here. And how it will work? Let's do a static analysis. A is initialized to 10 first. Okay, and this initialization happens only once in the starting of the function. Okay. And then whenever we call this function again and again here, it will come here, or do it this way. I want to call this function cyclically. I think only then we can properly demonstrate the use of local static variable with function scope. Okay. Even without brackets it will work, but I would always like to add brackets. for readability. Okay, so it will come here. Function 1 is called once a 0 10. So first time it will print 10, second time it will print 20. Yeah, because this is static. Let me initialize it with 0. Yeah, now I run the program. Now we'll see the value of a is 10 20 30 till 100. Okay, this is there. Next, I'll just remove this int from here, static from here. Okay, now you can see the real difference. Now what we have is just lot of tens. It means every time, because the local variable without static getting destroyed as soon as I come out of this function. Okay, meaning I'm calling this function 10 times here. Main function I equal to 0, call this function, come here, it will define a equal to a is 0, a equal to 10, printed 10. Come again, a is again defined. Okay, and it is again initialized, because all the local variables get initialized as soon as, I mean, they won't initialize explicitly, or they won't initialize implicitly. We have to initialize them on our own. Yeah. So, but the moment I add static here, this initialization for a static and global happens only once at the beginning of the execution, and then whenever there is an initialization after the first init, it's not done. Meaning, if I add a static here, every time the function is called, in this case, it's not going to happen that a will be initialized to 0. For that, I have to again write a equal to 0. Only with this statement it will update. So that's the difference between the this is the real use case of using a variable as a function scope static. Okay, you want to have a value persistency, but you don't want to make it global. Why you don't want to make it global? It's because, see, you are a function owner and you are doing some calculation with this. Okay, and you are using this a only in your function, but you don't want anybody else, the user of this function for this main, to update a. Okay, so then here if they try to do, before calling this function a equal to 10, then they straight away get a compilation error, because they will not get any way to update this variable which you are protecting to your function. So this is a main use case. You can very well make it global. Then the moment you make it global, you are exposing your variable to these people. Okay, I mean, these people, as in this example, I am writing both the functions, but in reality it will be completely different. Okay, you might be writing some 100 functions, the other person might be writing 100 functions. Then something which you feel should be protected by your function, or your design makes, if there are design decisions where you don't want others to update this variable, then you can make it local, not local static, static with file scope. Yeah, stop here.